A very warm welcome to everyone. I welcome you all for one more session on static routing using PNET Labs. We'll learn what is routing first. Routing is the process of forwarding packets from one network to another. The devices or the components which perform routing are called as routers. This routing happens in layer 3, that is network layer. Each router uses a routing table to find out the best path for data packets. It is of two types. One is called as static routing, other one is called as dynamic routing. Static routing is one which is manually configured by the administrator, whereas dynamic routing, the routes are learned automatically using routing protocols. Some of the popular routing protocols are RIP, OSPF, EIGRP, BGP. These are some of the dynamic routing protocols. The main difference between these two are again given here. One is static, is manually configured routes by network administrator, which is suitable for smaller networks. Whereas when we are going for larger networks, we can't go with static routing. We need to move on to dynamic routing. What is actually static routing is? In static routing, the path is manually set by the administrator. When suppose the devices are sitting in the same location, they are not moving at all. In that case, we can go with static routing. Here, the routers will not learn routes automatically. Manually, it has to be configured. Each route must be defined using the destination network and next hop address. It is a little bit complex process of giving routes manually, and the syntax for giving this static route command is router IP route followed by what is the destination network, what is subnet mask of the destination network, then next hop address symbol. If suppose I am pinging from 1.0, then my destination is somewhere in 2.0, then my command will be like IP route 192.168.2.0, that is destination, followed by subnet mask 255.255.255.0, then followed by next hop. Who is the next person sitting who can take my packets and forward them? That is the next hop address. This is how you can have the syntax for static routing. Why do we use static routing? Static routing mainly used for smaller size networks. It provides greater control over traffic paths. Since the network is small, traffic can be controlled in a very nice way, and there is no overhead from routing protocols. There is no burden from routing protocols since it's static and manually configured, no traffic, small network, so no overhead for that. And it is very useful for testing and learning the basic routing concepts when we will not use this static routing. As I said, it is not ideal for large or dynamic networks. And here, manual updates are required if network topology changes. As I said, it is good for fixed network. If suppose people who are sitting in a small lab which are having some desktops which are fixed, then I can go with the static routing. Whereas if I am having a larger network or my nodes are keep on moving, then I cannot use the static routing, and it is not possible to find out the fault automatically. So in such places we will not use the static routing. So with this small introduction, we will directly move on to how to set up a static routing using PNET Labs. Here we are going to use two routers and two switches, and 4 pieces will use 2 PC for each switch, which means I'll be having 2 networks. I'll make sure that 2 networks are communicating with each other. Those 2 networks are different networks. Let us say if I'm having 1.0 network, other one is 2.0 network. With the help of the static routing concept, I'll make sure that we are able to send packets from one network to other network. So the main objective for today is to configure static routing so that PCs in LAN 1 which can communicate with PCs in LAN 2, which means one network to other network. Let us see how this is done. As I said, the objectives are clear now. We'll assign the IP addresses to all the PCs and router interfaces. Then we will configure the routing. Then we'll add the static routes using the IP route command as we have discussed just now, and verify the connectivity using the ping commands. Now this already we have discussed. Now this is the topology what we are going to do it today. As we have learnt concepts on basic switch configuration, creating a small LAN, by now you are familiarized with how to establish a topology. Here I am having two switches. You can see switch number 1 and switch number 2. Two switches and two routers I have taken, and two different networks. We can see here I have 1.0 network, whereas this is my 2.0 network. I am going to make communication from 1 dot network to 2 dot network with the help of the routers. I'm going to use a static routing concept here. This topology, I have already built this topology, but I have not given any commands inside, just a physical topology. Dragging and dropping those components is done, and labeling is done outside. This part I think you can do it. If you do not know how to do this drag and drop, please do watch the other videos of LAN or basic switch configuration, so you will be able to know. Then you can able to come to this video. So now we'll explain what are the things we are going to do it today. So here first we are going to move on to one of the router, say router 1. Then I am going to rename that as a host name as R1. This is for just for understanding purpose. Then I am going to find out the interface which is connected to the network. See here, this is FE0 bar 0 is connected to this particular network. So this is going to be the gateway for these devices. So I'm going to assign this. So here 192.168.1.100 I'm going to assign it to FA0 bar 0. FA0 bar 0. Then I'm going to declare it as no shutdown. Then interface FA0 bar 1. What is FA0 bar 1? This FA0 bar 1, I'm going to give this IP address. See, I have assumed everything as /24, which means the mask is going to be same for all the devices. So again, then here comes the IP route command. This is the important command for static routing, as we have discussed. IP route, destination is my 2 dot network and its subnet mask, followed by next hop. See, from here, from this router I am saying the next hop is 10.10.10.2, 10.10.10.2. So the same thing I'm going to do it for the other router also, nothing else. So after that I'm going to assign the IP addresses to the PCs. This I think you know how to assign the IP addresses to the PCs. If not, please do watch the other videos and then come back again. Now let us start the lab session. These are the some of the verification commands. This we will see directly when you're doing the lab show commands. I have already opened my lab and kept. So this here I have not done any configuration here. Just I have pulled the images of the Cisco and Cisco's switches and routers, and I have given the labels just for understanding purpose and for quick learning. Now I'll turn all these devices on. Just turning all the devices on. Now all the devices are on. So what I will do, I'll move on to one of the router. I'll open one of the router. Let us say R1 router. Go make configuration. Yes, so with the first command, as we all know what is the first command, enable. Then second command is configure terminal. Then configure terminal. After configure terminal, as I said, we will change the host name to R1. Host name to R1. Now you can see the change host name is changed to R1. Now what is my interface which is connected to the 1 dot network? It is FA0 bar 0. So interface FA0 bar 0. I have taken the interface FA0 bar 0. I'm going to give the IP address 192.168.1.100. This is going to be my gateway. This is going to be my gateway for my device. Then followed by the subnet mask 255.255.255.0. Then I should give my no shut command, no shutdown. Then the other interface is interface FA0 bar 1. Correct, FA0 bar 1, am I right? Yes, FA0 bar 1. Then the command is IP address 10.10.10.2 followed by 255.255.255.0. Yes, then my command should be no shut, no shutdown. Yes, I can exit from this mode now. Exit from this global configuration mode. Then I can give again conf t. I can give my IP route command. IP route. What is my destination network? 192.168.2.0. Then followed by 255.255.255.0. And what is my next hop here? Next hop is 10.2. 10.10.10.2. This in this router. Next hop is in this router. How it is in this router? 10.10.10.2. IP route. I have given the IP address 10.10.10.2 for this. So I'm giving it as 10.10.10.1. Here a simple change in making my topology. So this will be now 10.2 and this will be 10.1, just for understanding. So here I am IP route 192.168.2.0 255.255.255.0 then 10.10.10.1. Yes, then I can give end. Then after this I can write my memory. Write memory. Yes, now it is done. So same thing I need to do it for this router also. Let me move on to this router. No. host. No, first I should give my enable configure terminal. Host name is R2. Then I'll give my interface. What is the interface which is connected to 2.network? It is FA 0 bar 0. Interface FA 0 bar 0. Then what is IP address? IP address 192.168 1 dot 100 followed by 255.255. Sorry, it's 2.100 followed by 255.255.255.0. Then no shut command. This down. Then after that I'll take the one more interface here. What is the other interface? It is FA 0 bar 1. Interface FA 0 bar 1. Then the IP address is IP address 10.10.10.1 followed by 255.255.255.0. Then I'll give no shut down. It is done. Then I can exit. Okay. Then I can exit from this mode. And my command will be, I need to give the route conft IP route. What is my destination? 192.168.1.0 because I'm sitting on 2.0 router. And then followed by 255.255.255.0. And what is my next hop now? 10.10.10.10.2. 10.10.10.2 is my next hop. And after this I can end. Then I can write memory building configuration. Okay, now I have completed the routing part, which means in this I have completed the step. The routing configuration for both routers is done. Now I need to assign the IP addresses for the individual pieces, that we know how to assign the IP addresses for the individual pieces. So I'll move on to this PC. So 1.1 network. So IP 192.168.1.1 followed by 255.255.255.0 subnet mask, and then my 1.100 gateway is subject to check for the duplicate address. If no duplicate address, it is assigned for this PC. Next I'll go to this PC as well. Again IP 192.168.1.2 followed by 255.255.255.0. Then the gateway 192.168.1.100. Then it will check for duplicate. Now there is no conflict with these two IP addresses. Then now let us move on to these two IP addresses assigning. I'll assign for this first for this PC with 2.1 network. Console 190 IP, sorry, IP 192.168 2.1 followed by 255.255.0, then followed by 192.168 2.100. Done. Similarly, I'll assign for this particular PC also. IP 192.168 2.2 followed by subnet mask, then followed by the gateway check for the duplicate address. No duplicates found. So now it is done. It is now done. Everything is done now. I need to just try for pinging. I'll just try for pinging from one of the PC. So I'll move on to one of the PC. Okay, so this PC IP address is 1.2. From here we can see it is 1.2. I'll ping from this PC 2.1. Ping 192.168.2.1. Let us see whether it is pinging. Yes. So now it is, we are getting a reply here. Similarly, I'll ping for 2.2 also. Ping 192.168.2.2. I should get some reply. Yes, I'm getting some reply, which means the packets are sent and received. Now I'll take one more PC. From this PC it's 2.1. I'll ping for 1.1. Ping 192.168.1.1. So first packet is lost. Other packets are sent successfully. You can see that packets are sent successfully. We have some show commands also. We will see that show commands also now. From the router, we can check for the interfaces brief. Let us try with this router. Show IP interface brief. So it is we can see like we have two interfaces with the IP addresses and both are up. Like this we can verify the connectivity also. So I can ping to my router also. Ping 192.168. It is 2.100. Yes, I'm getting reply from here. So like this we can do the static routing. Now we have completed the static routing. For all the devices we have done the IP addresses. We have completed the static routing. Thank you all. Next we will discuss about the dynamic routing.